Welcome to the Modern Application Development Screencast. In this short screencast, we'll learn how to use database or schema migrations. Before we start, open the following applications on your Ubuntu desktop so that you can work along with me. Browser, preferably Firefox, Chromium or Brave is also fine. An IDE or a text editor. I'm using Sublime here. Terminal. And please also make sure you have a copy of the project that we did in the last screencast so we can continue quickly from there. Until now, we've been maintaining the database schema manually, which means we're adding columns, tables manually, we're adding or removing the constraints manually by going to the database. But we can do it programmatically in code. This makes it reproducible and versioned, and this is called schema or DB migration. If I have to define it, then DB migration or schema migration refers to management of incremental, which is like a step, one step by one step, and reversible changes to the relational database schema, and sometimes data too. For example, if you add a new column, what should be the default value? If it's a calculated column, then you will add a default value based on the calculation of some other columns, etc., etc. So you also do sometimes manage the data. Schema migration is performed on the database to update the schema or reverse the database schema. For example, in this version of code, you have a role table, but if you want to revert the code, you also want to revert the schema, because you don't want to have the role table there or some other change like that. So you can use it to go further or go back. Schema migrations are represented as code like I told you before and is maintained in version control just like code. This helps us to keep application code and application database schema in sync. When you check out any version of code, it will also come with particular schema so that they are always in sync, because you are maintaining schema also as part of the code. This actually helps to reduce the impact, though it's not always promised, but it does reduce the impact. This is really helpful if you're working in a team, that you are multiple people and you're working in team and trying to synchronize the schema changes and stuff. Or also, if you're maintaining different environment, for example, you have 3 or 4 environments like local development, staging, beta test, and and actual production. Now, as and when you actually deploy the code, you also want to deploy the version schema. So hence, DB migrations help in that scenario as well. All in all, even if you work alone, or if you have only one environment, you still maintain this so that it's easier to revert or go further at any point you want to do. And that's also a good practice in general. In our code, until now we have been running all of this manually. Like for example, we had a test DB that we used to insert or update manually. I'm just going to open that up. Right. This is all we had, and we added all the tables, etc., manually. Now I'm just going to delete it or rename it just for the sake, so that we can generate it automatically using schema migrations. So after I do that, I actually want to install a package called Flask-migrate. Right. Before I do that, I go to my command prompt and I will import or activate my virtual environment. So I'm going to do source.env bin activate. Okay. Now to actually manage our schema migration, we are going to use a package called Flask-migrate. It internally uses a package called Alembic. Right, Alembic is a very generic schema migration tool for SqlAlchemy. You can search and read more about that here. So it helps you to do schema migration in general, right? Here, this one. Now, I'm going to use the Flask-migrate, which actually simplifies it. That's it. If you want, you could use Alembic too directly. Let's install this. You could add it to requirements.txt and run again, but I'm just going to install it here directly now. Right, it's installed. Now we have to make one more small change in our code where we define our application. Go to our main.py. Here, when we're defining the application, when we initialize the DB, we should also initialize the migration. So we can just do this, and to do this we have to import the migrate. So since we installed it, we can just do this, right? Now we have done all the work that is required for Flask-migrate, and we have initialized that too. I think it's app is app, DB is DB, that's correct. So this is all done. Now we can go back to our command prompt. Here I'm not, initially we had run local setup, local testing, etc. Here I'm going to run directly. You can create some helpful scripts if you want later. Right here, I'm just going to use the environment as local environment. So I'm just going to export env is equal to development, and my Flask app is in main. So I'm just going to export that too. Right, so now I should be able to run Flask commands. To actually do the initial setup, I'm going to do Flask db init, right? So this will actually create all the migration folder, versions, and details about configurations, Alembic related configurations, etc. So let me just run it. So it has run. So you can see that it has now created a folder called migration. It has created a folder called versions, though it has nothing. And it has created env.py, which is, we are going to make some changes here, but this migration specific code, then some configuration here, right? We will not change anything as of now. We'll keep them as it is. Let's go back. So it's been initialized. This is a one-time effort. We are going to commit this into code. If you're maintaining a repository, you can add this folder into your repo, like so that it's checked into your jet and shared with your team, right? Now I want to create the initial migration based on the models that I already have. Here in our application, we already have models and we have already defined tables. We should be able to create these in our database directly so that it's so much easier to use them, right? Or actually, we should be able to create tables using this so that we don't have to create manually. So I'm going to create the first migration script called db initial migration. db initial migration. I'm just going to paste the command and explain it. So here I'm calling db migrate and I'm just passing the message as db initial migration. This is just for our understanding. It also puts in comments and uses it in the file naming, but mostly for our human understanding. When I run it, it actually goes through the models and checks whether the table exists. It doesn't see any tables. It will actually create the initial table. It will try to run the check the models in it. It doesn't exist. So it tries to create the tables in our migration. So if you go to migrations now, if you check versions, it's created the first migration. This is an automatically generated number. Don't change it. You don't have to do anything. This db initial migration is our comment. Now if you go check you can see that it is written all the scripts that is required to create the tables, right? Now, even though it has created everything, we have to double check it to see what all it has created and whether it's correct, right? And here there is an article search table 2 it's trying to create. Now we don't want this to be created. As you remember, article search was created as a part of FTS and it's a virtual table. I don't want to create like a real table based on it. Even though we have a model, we'll come back to that and I'll tell you how we can stop doing that, but we don't want to do it. So I'm just going to remove that. All right. And then it's creating article, role, user, article authors, role authors, and you can see the upgrade creates all the tables and downgrade removes all the tables. So you can, at any point you can go upgrade, or at any point you can go back by calling downgrade. Right. Now let's do upgrade. Before we do upgrade, let me just check this this newly created testDB SQLite, right? As you can see, it has nothing. It has only one table called Alembic version, which is empty because no Alembic upgrades were run. This table is created automatically for migration references to check at what version this database is at. Once we migrate, it will update this this table and this version column, right? This version column. Now let's run that upgrade. Right? Let's go here, call this. Okay, so it has run. It is saying running upgrade. This is the version number, DB initial migration. It's completed. Now if I go and refresh this, you can see that version number has been upgraded to what version ran, which is this 87 whatever. You can see that here, 87, the specific revision, the same thing, and you can see all the tables have been created automatically. You can check all the tables if you want to. There's no data, but all the tables are created, correctly. Now I want to create an empty revision. This was created automatically. I want to create an empty revision so I can add FTS tables manually. Sometimes you actually create migration scripts automatically, like the one we saw now. Sometimes we create it manually for things that we want to run specifically manually, right? So let me create an empty revision. All right. Okay, Flask-db revision -m add FTS. So it has created this revision called F0 whatever underscore add underscore FTS. So if you see that revision here, it will be an empty revision. All right. Now I want to create a virtual table called article search for our full text search that we had done in our full text search screencast, right? So we can do that by running this query. So here I'm writing the migrations manually. In downgrade, I'm just going to drop the table, right? I'll drop this virtual table, right? Here. Correct? So this is what we had done manually, so I'm running it automatically now. Now you can upgrade again, or you can create one more revision to do some more things and upgrade it together. So let's upgrade again. Something is wrong. So this is just an import. We have to import from SqlAlchemy this text class to run it. We can just do that import, right? Let's do that. So I'm just going to import that. I just missed importing this because we are manually creating the query and running the query, right? Okay, let's run this again. So it ran. So if I refresh it now, I'm not going to do anything. So you can see that it has created article search and all the related tables for FTS, right? Now, as part of FTS, we also had to create triggers. So let's do that. We'll create another revision. Here I'm not doing actually migrate. You can see that I'm just creating a revision. Revision just actually creates an empty revision, okay, empty table. When you do migrate, it tries to see the differences in the database and in the model file and tries to create the schema migration automatically. Here I want to create an empty file with just a structure, and hence I'm using revision. Okay, so it created another empty revision file here. So now I'm just going to add some triggers. We had 3 triggers, one for delete, one for update, one for insert, and then downgrade is just dropping those triggers, right? So now I'm just going to import the same text because we are using it, right? And then I can run it. You can also do all of this in transaction. So if one of them fails, everything fails. It's actually better to do all these 3 within one transaction and commit it at the end, like you would actually do in a regular code, so that it will create all of them or doesn't create any of them, right? Okay, let me run this. Flask DB. If you enter just Flask DB, it actually shows all the options available, right? You can do that also. Now Flask DB upgrade. So it ran everything. So it would have created triggers too. Now you can see it has created triggers too, right? Now we have set up everything, right? Now let's say you want to create a new model, and you want to actually instead of inserting it, we want to actually create using migration. Okay, so let's say you wanted to add article categories. So we are going to define 2 models, right? Let's go to models, create 2 models. One is category, which is defined like a standard set of categories, and then there is article categories where you will associate article with the category, right? Now previously we used to go to database and create them manually and do all of those. Now we won't do this. Now what we'll do is we will do db upgrade migrate and try to create the migration automatically, right? So I'm going to create Flask DB migrate minus adding article categories. Let's generate it. Let's see what it does. Now, quite interesting things happened here. Let's go to this migration. You can see that it's creating category and it's creating article category, but it's also trying to drop these tables, right? Similarly, it's trying to create all those tables. Now, this is happening because these tables were created as part of our manual creation, and this actually doesn't exist in our model. For example, if you go to our model, this article search IDX, article search data, and config, etc., doesn't exist, but it exists in the database. It exists here in the database, for example, this table, but it doesn't exist models. So it trying to sync it and it's trying to delete it, and I don't want it to do that, especially because these were created, through another script. I don't want it to drop them. So I'm going to make my migrations to stop deleting automatically, or to stop dropping the tables automatically. And also you could see that it's trying to update the virtual table article search with row ID, right? And this article search is not created using the regular create table. This was a virtual table, and then I don't want our migration to automatically include that in our automatic migration creation. Hence, first I'll just delete this and I'll make some changes, right? What changes I'm going to make is mark this table as virtual, right? I'm going to mark this table as virtual and then exclude virtual tables from automatic creation, right? I'm going to use table arguments and set up info and make is virtual is equal to true, because this is a virtual table. For rest of them, it's all false, because as you can see, article search is for our reference, but when we are actually creating it, we were creating a virtual table. It's not a full-fledged table, right? And if you could see here, we are creating a virtual table, right? So let's go to models. So we have set up the table arguments. Now we want to exclude this while creating the table. That can be done by changing the config in our env, right? env.py, which is used by Alembic to run the migrations. Now to change here, what we need to do is change a function called include object. You can also see that in the description. I'm going to share a link. So this is the same, it's a cookbook. Here. So I'm going to use this both. One is don't generate any drop table directive with auto generate. Also exclude all the virtual tables. So I'm going to write, go to env and write a function called include object, right? Which will actually do the following. Right. So here is the include object. I'm going to just follow the standard. It's a little bit different from this because I'm doing two things here. If the table type is, if the type of the object is table and it's not present in the database, or then don't automatically delete it, return false, right? That's one thing I'm doing. But then going further, if the table type is virtual, then also return false. Only otherwise you return true, right? This is what I'm going to do. You can read about include object and details of it here in the Alembic site, right? Now I have to use this in the configure. So while setting up the context. So here is one context configure. So I'm going to pass include objects that needs to be included as part of migration, right? And there one more time. So every time the migrations run, whether online or offline, it will call include object to see whether this object, whether the table, virtual table, column, etc., needs to be run. Then it will check this. If this returns false, it won't include them. If it returns true, it will include them. Here, hence we are adding the changes. Whenever we don't want it to be included, we are returning false. After this, now let's run the, since I have deleted the migration, let's run the migrate again. Okay, oh, this is just printing from this print. You can see for every object it gets called, right? Now here if I go, So it's only handling category and article categories. And in case of downgrade, it is deleting the categories and category. Now, if I run upgrade, it's running the migration, and you can see that there is article, categories and category, right? And you can see our Alembic version 2. It's the latest version 780, right? You can see the path as well. If you go to Flask-db, let's check all the things. Flask-db, history. It will show you what ran after what. This ran first, and then this ran, and this ran, and then this ran. Now we are at this level. Let's say we want to downgrade, right? What should ideally happen? If you downgrade, this should go away and it should come to this level, right? And which means when you downgrade, the latest tables created category and article category should go away, right? Let's do that. db okay, it's downgraded. Here, if I refresh, you can see that it's gone. The tables are gone, right? And now if I do history, you can check that these are the things, and you can check at what level it is, current level is, you know. Here can do heads. You can see that it's at this level, right? So that way you know at what level you are, and you know where to go, where to retract to, or go downgrade or upgrade. Now I can just go again, do an upgrade if I want, right? So if you check, if I refresh this, tables will get added again. That's how you actually manage the migration. Now if I am in another environment, I can run from the beginning. For example, I can delete the whole table. Let me just close this table. So now you got this code, you are checked out, you don't have a local database, you delete this. You can do so it will run everything, all of them, and you can open that thing file again to check whether everything has been run. Right, our last change was this, so that Alembic shows that and all the tables exist, right? So this is how we actually maintain the migration and run the migrations, right? So just like code, just like how we maintain JIT to go up in history or go back or go front in history, you know, by checking out specific points. Here we either upgrade or downgrade to go a specific revision in the database. This actually will be very, very helpful if you're developing an application over the time. Like, you know, you're adding features by feature, one by one, and then, you know, you're adding smaller features, you're removing the column, adding the column, and things like that. Or you have a team which is working on 2 different features and then you want to bring them together. You can actually commit the migration, they can check out and they can add their revision, and you can merge. You can maintain it just like the way you would maintain any other code. This will be very helpful to actually run any kind of sizable project. I think you should really practice it instead of creating the tables manually, at least for the project. Thank you so much for watching.